occurs. Sometimes an electric circuit that looks at the first sight so simple with just one voltage source and several resistors turns out to be a complicated one in the long run because of the arrangement of the resistors. Once you make out which resistors are connected in series and which resistors are connected in parallel, things get easy for many circuits. Let me show you two circuits one by one. Circuit 1. The equivalent resistance between the XY terminals in the following circuit is to be determined. There are no resistors in series, nor are there resistors in parallel. Thus, this is a complicated circuit. Applying Kirchhoff's junction rule followed by Kirchhoff's loop rule to the circuit, you will obtain 3 or more equations, solve them, and finally get one more equation to find the equivalent resistance. I guarantee you will experience some hectic urge to solve this. Let me let you encounter another circuit. Circuit 2. The current through the 8 ohm resistor has to be determined. At the first sight, the circuit may look so simple. This part of the circuit is a Wheatstone bridge. If this is a balanced Wheatstone bridge, the diagonally connected 6 ohm resistor becomes useless, and the removal of this 6 ohm resistor will get the solving so easy. However, this is not a balanced Wheatstone bridge. You are again going to pass through an ordeal to get the current through the 8 ohm resistor. Then, what's the way out? Let me introduce 2 essential gifted tools that will prove handy. They are star to delta conversion and delta to star conversion based on Kirchhoff's junction rule and Kirchhoff's loop rule. This is star connection of 3 resistors. A star connection is same as a T connection as shown in the figure. The following is how a delta connection of 3 resistors looks like. A delta connection is same as a pi connection as shown in the figure. The following are the formulas for the conversion of a star connection to the corresponding delta connection. The formulas of the resistances of the star connection corresponding to a delta connection are given below. Sometimes a star connection may be complicated, and the corresponding delta connection removes the complication. In this case, we need to convert the star connection to the corresponding delta connection. Let's apply the star to delta conversion idea to circuit 1 already shown in an earlier slide. We need to find the equivalent resistance between the XY terminals for the circuit given below. This star connection in the circuit leads to complication. Let's replace this star connection with the equivalent delta connection, keeping all other resistors intact. The circuit containing the equivalent delta connection is given to the right of the original circuit. Let's now find the resistances of the resistors of the corresponding delta connection. Let's give a simplified look to the converted circuit. Further simplification helps us find the equivalent resistance between the XY terminals of the original circuit in the following way. Again, sometimes a delta connection may be complicated and the corresponding star connection removes the complication. In this case, we need to convert the delta connection to the corresponding star connection. The problem of circuit 2 already shown in an earlier slide falls under this category. This Wheatstone bridge is unbalanced. Why is this unbalanced? Let's check it. The product of the resistances of the resistors in these opposite sides is not equal to the product of the resistances of the resistors in these opposite sides. So we cannot remove the diagonally connected 6 ohm resistor. This Wheatstone bridge contains 2 delta connections. One is this and the other is this. The delta connection on the left has 3 identical resistors. So replacing this delta connection with the corresponding star connection or T connection that will also contain 3 identical resistors will turn out to be easy. Let's now convert this delta connection with the equivalent star connection. The circuit that contains the equivalent star connection or T connection is to the right of the original circuit. Let's now calculate the resistances of the delta converted star connection. Let's give a simplified look to the converted circuit so that the equivalent resistance of the whole circuit can be calculated and the current through the 8 ohm resistor can be determined.